Welcome back. These are videos for lecture 14 of our CSI 31 class. The topic is recursion. Okay, let me read a bit of chapter on recursion, page 1 of our file OOPP PDF. Okay, this is an important part. So, in this particular topic, we introduce another form of repetition known as recursion. All right. We have seen repetition in the form of for loop, while loop. Now, recursion is another form of repetition that can be used to design classes and functions. We begin by demonstrating structural recursion. Structural recursion is a natural way to define objects that have one or more smaller instances of the same class as attributes. For example, here is a pyramid. It has 8 levels 1, 2, 3, 4, 5, 6, 7, 8. You can view this pyramid as a base and another pyramid sitting on it 1, 2, 3, 4, 5, 6, 7. You understand? A base upon a 7-layered pyramid is an 8-layered pyramid. So this is an example of an object that has one or more smaller instances of the same class as attributes. Okay. So the 8-level pyramid can be viewed as a single bottom level with a 7-level pyramid built on top. Now that 7-level pyramid is itself a bottom level with a 6-level pyramid on top of it, and so on. Okay. Eventually we reach a so-called base case in which recursion is no longer necessary. For example, a 1-level pyramid is a single block. In this chapter, we consider 2 detailed implementations using structural recursion. Okay, we will see many examples in very soon. All right, so I hope this is clear. Structural recursion is a way to define objects that have one or more smaller instances of the same class as attributes. A second form of recursion is called the functional recursion. It occurs when a behavior is expressed using a smaller version of that same behavior. Okay? For example, a common childhood game involves one player guessing a number from 1 to 100, while the other gives hints as to whether the true answer is higher or lower than the guess. A wise strategy for a player is to guess the middle value, in this case 50. If that guess is not correct, the hint will narrow the remaining search either to the range 1 to 49 or the range 51 to 100. The strategy at this point can be described as a repetition of the original strategy, although adapted to consider the currently known lower and upper bounds. Much as a function can call another function, it is allowed to recursively call itself. You understand? A case where a function calls itself or a method calls itself, that form of recursion is called functional recursion. Okay? Functional recursion is different from structural recursion. Structural recursion is where an object has one or more smaller instances of the same class. All right. So right now, these videos today for lecture 14, we will focus on structural recursion. I have uploaded all the relevant files in Blackboard content, lecture 14 files. Okay. To find it, go to content. You will find codes for lectures, code for lectures, lecture 14 files, all these files. I have also uploaded all these files in our Dropbox. Okay, lecture 14 files. So let's go through one file at a time. Let's start with startriangle.py. Okay, startriangle.py. I have downloaded all these files already, so here it is. Okay, looks like I have an iterative version and a recursive version of the same program. So let me play with one program at a time. So at present, I'm going to play with the iterative version. So let me run it and show you what it does. Please enter a positive number, integer. So I press 10. Looks like it's printing 10 stars, 9 stars, 8 stars, 7, 6, 5, 3, 4, 2, 1. Okay, so this is the purpose of this particular program. What does it do? You give it a number and it will create a triangle of stars. Okay, so now notice the code. First, I'm defining print stars for n. I'm going to print n number of stars. New line is implied in a print. Okay, by default setting, I will print n number of stars and continue. Okay, so that is just drawing one line of stars. What does print triangle do for n? It goes through a for loop from n plus 1 to 0 with a negative 1. Maybe I am drawing too many things. So let me do n to 0, negative 1. So I'm going down and I'm printing I number of stars, print stars I. Okay, and eventually I have this main function, so which has prints. So print stars is a helper function for printing of triangle. Printing triangle, print triangle helps my main function. So let's start with a seed value, n equals negative 1. While n is less than 1, so I get that seed value to get into my while loop, enter a positive integer. All right, and then whatever n I get, I will print triangle. All right, so run it again. Enter a positive integer. So suppose I give it negative 10. It's still asking. Suppose I give it 0. It's still asking. Suppose I give it 7. Now it's able to print. It prints triangle. Okay, it gets out of the while loop once I give it a positive integer, and print triangle is done with a for loop. This is an iterative version. Okay, so here is the recursive version of the same code. Okay, so let's play with this. Oh, all right, make sure it works. All right, please enter a positive integer. So say I give it 8 and it's drawing. So what is the recursive version? My print stars is the same as before. It draws one line. Okay, but print triangle has changed. For any n, first draw one line, n number of stars. Okay, now if my n is greater equals 2, so this would happen if n is 1. So that is my base case. Otherwise, n is greater equals 2, print triangle n minus 1. So after you draw the first line, the rest of it is another triangle with one less starting level. Okay, so in other words, print triangle as a function is calling print triangle as a function. So this is an example of functional recursion. Okay, this is a simple exercise to help you understand how recursion works. Okay, so this is an example of a functional recursion. I have a function, within it I'm calling the same function. That is recursion. Okay, so now I'll continue next video. Until then,